Hello, my name is Chua, and today I would like to present my experience report on learning functional programming and effects with Koka, a functional programming language with algebraic effect handlers. My research topic was on functional programming. Functional programming is a programming paradigm where programs are constructed by applying and composing functions. It is a declarative programming paradigm in which function definitions are trees of expressions that map values to other values, rather than a sequence of imperative statements that update the program's running state. Functional programming has its roots in academia, evolving from the lambda calculus, a formal system of computation based only on functions. Traditionally, it has been less popular than imperative programming. Today, functional programming has its applications in academia, education, and the industry. I chose this topic because functional languages can be challenging for beginners to learn and understand, especially those coming from a procedural or object-oriented background. To learn functional programming, we have many things to unlearn, so to speak. Besides, a lot of the material out there isn't targeted at beginners, and there aren't a lot of resources to learn the difference between functional programming and other programming paradigms. The research I conducted was in the form of an experience report. Experience reports are a reflection of a person's own experiences. For example, the challenges they have seen, what they've tried, and the approaches they've taken, what worked and what didn't work, while implementing real-world scenarios and solutions. I used Koka, a strongly typed functional style language with effect types and handlers to implement data structures and design patterns typically found in object-oriented languages. Previously, I've only had experience with Python, C++, and other non-purely functional languages. Me and my mentor chose Koka as a language to explore functional programming. A few features that distinguish Koka from other languages are its effect typing and effect handlers. Koka tracks the side effects of every function in its type, where pure and effectful computations are distinguished. Effect handlers let you define advanced control abstractions, like exceptions, async, await, or probabilistic programs, as a user library in a typed and composable way. They are typically used to handle effects, thus the name effect handler. However, as Koka is primarily used to run scientific experiments, there haven't been many implementations of various basic tasks. The Koka documentation may also contain terminology and expressions that may pose a challenge for beginners attempting to use the language. There also aren't many accessible ways for beginners to learn functional languages as a result of bad impressions left by courses taught to students in the past. Therefore, many end up intimidated and may not even attempt learning functional programming or give up after a while due to the lack of information available. I believe that it's interesting to see people's learning journey when faced with this type of language, and especially as a beginner, a lot of things can be taken away from hearing initial common misconceptions about what the correct way of thinking in functional terms is. Therefore, I believe that this paper can serve as a great way to allow beginners to start to understand the difference between functional languages and languages of other paradigms. In this paper, I go through my experience implementing a factory design pattern, a linked list, and also some combinator functions. I also implement an iterator for the linked list, tying into the iterator design pattern. I tackle some problems that beginners may face while learning a language with incomplete documentation such as Koka. For example, the matching section, which is used to compare enums in Koka, was missing. I also had some trouble understanding notation at first. For example, the statement written below means that the type of action is a function with no arguments that returns A and invokes the effect emit type E. I was really confused about it at first, and I would imagine that many others would feel the same way. E and A are used as generics. However, this is not explicitly stated in documentation, which may confuse those trying to learn the language even more. At first, I was also really confused about how effects and effect handlers worked in Koka, thinking that they were simply exceptions or a way to show any possible consequences that would disrupt the normal flow of the program's instructions. In the end, I learned that they are simply a way of providing a function and anything it calls with effect handlers, which can be user-defined. These effect handlers are carried out when their respective effect is evoked. A few other problems I faced were matching enums, working around the immutability of user-defined structs, and misunderstanding effect typing in Koka. I cover these misconceptions and more in the experience report. To summarize what I did in my paper, I go through my experience in understanding how algebraic effects, data structures, matching, and many other elements of Koka work. I explain my initial thoughts and misconceptions for tackling these challenges and suggest ways to correct them to align it with functional programming. In conclusion, Koka and other functional programming languages possess a steep learning curve, especially to those who have never encountered such paradigms before. I hope that this experience report will serve as a good point of guidance for those attempting to understand the functional programming paradigm. I have linked the code I wrote below and the references I've used. Now I'll be talking about my experience in Talaria. This was a really incredible experience for me. Talaria allowed me to delve deeper into computer science and also grow as a person. Not only did I learn a lot about functional programming, but I also learned how to deal with any difficulty that was thrown in my way. For example, I had quite a lot of trouble trying to understand the basics of Koka, but with the help of my mentor, I persevered on and even managed to complete my paper, something that I thought wouldn't have been possible before this camp. This experience has made me more curious, determined, and really encouraged me to continue pursuing computer science. As for my mentor, working with someone established in the field of programming languages was really beneficial for me as he provided me with lots of support. Honestly, I probably wouldn't know how to tackle more than half of the problems I faced without my mentor. He was also really responsive, although I know that they typically have a tight schedule, which I'm really grateful for. My mentor really helped me understand my mistakes and taught me about functional programming. Previously, I only had a faint idea of what functional programming was, but after the guidance of my mentor, I feel a lot more comfortable with functional languages and what they entail. Thank you so much.